Okay, sorry, I got pulled away for a second there. So let's see, let me see where it stopped. Okay, so we're graphing, we're looking at b greater than 1, okay, and just like we had with the exponentials, we're gonna have these two different graphs. So the thing is that everything here is gonna be opposite of what the exponential has. So they're inverses, so they do the opposite. So the exponential had a horizontal asymptote, so the log graph has a vertical asymptote. And the exponential had that point that was 0, 1. Well, flip it around and the the log has the point 1, 0. And then this graph, it looks a little bit different. It's gonna come from below, hug that asymptote, and grow. So looks similar to the exponential, but not quite. It's got opposite point, opposite asymptote. Now, there's the second graph, which also looks like y equals log base b of x, but this is, again, if our b is between 0 and 1, so like 1/2, 1/3. Now, this graph also has that vertical asymptote. Also has that point 1, 0 on it. But this guy is going to be decreasing instead of increasing. So it looks something like that, hugging that asymptote up here. All right, how does that look? Now, just like we have done before, we can take these graphs and we can shift them around a little bit. So let's do some transformations. So let's say I wanted you to graph, let's graph y equals log of x plus 2 minus 3. Okay, log of x plus 2 minus 3. So, same thing as always, base graphs, transformations. So, nice big graph on this guy. Now, did I leave off the base, or is there a special base there? So remember, when it's not there, that base 10 is implied. So we're looking at a base bigger than 1. So we're looking at this situation. So we'll start with our asymptote, vertical asymptote. We'll start with our point 1, 0. But remember that this is just our first sketch, so we're just going to dash it in like that. So it's increasing, looks something like that. Okay, then we're going to start moving it around. So here, the next thing we're going to do is the x plus 2. And now the 2 being in with the x, this is going to be our horizontal, but which way are we going? Plus 2 means we're going to go in the negative direction. And who else has to move besides the graph? The asymptote, doesn't it? So the asymptote is going to come over here, come 2 units over. Then the point is going to come 2 units over. And then we're still just going to sketch it in like that. So now here is our vertical asymptote. We'll make it big and bold so that I can see it. And then we need to take the whole graph and we're going to go down 3 units. Okay? So if we go down 3 units, the vertical asymptote is shifting down. That's not really going to affect anything, so we just can leave it there. But that guy is definitely going down 3 units, right? So 1, 2, 3. So our new point will be right here. And now it looks like I possibly crossed my asymptote, but if you think that your graph doesn't show exactly what you need to know, you don't need to erase it or redo it. Just say, like, make a little arrow and say, shouldn't touch, or something along that line, so that I know that you know what the asymptote does. Okay, so this is kind of a short section in that we're just introducing the logs to you, showing you from exponential to log and log back to exponential, and then looking at the graphs. Okay, so now you should be able to do all of 6.1 homework. Last time we saw some of it, but now you should be able to do all 6.1 homework. And then we'll come back and do 6.2, and that's going to get us a lot more information on the logs. All right, I'll see you next time.